proceed with chapter 3, the relational database model. In this chapter, we are going to look at the logical view of data, table and their characteristics, key integrity rules, data dictionary, and the system catalog, relationship within relational database. Okay, what does it mean by a logical view of data? Okay, first, we recall back about a relational model. So, relational model enables programmer to view data logically rather than physically. Okay, so table resembles a file from conceptual view, a point of view, has advantages of structural and data independence, easier to understand than its hierarchical and network database predecessors. Okay, so relational model ni adalah satu cara bagaimana programmer melihat data itu secara logically. Maknanya human's view of the data. Okay, rather than physically. Okay, try to recall back. Physical view means how the computer look at the data. Okay, so table resembles a file from conceptual point of view. Okay, so table ni menyerupai file dan dia mempunyai kelebihan dari segi structural and data independence. So recall back the term structural and data independence. Maksudnya sekiranya structural independence, sekiranya struktur data itu berubah, dia tidak mengubah cara untuk access kepada data itu. And then easier to understand than hierarchical and network database predecessors. Jadi dengan adanya table ni, data itu lebih mudah untuk difahami berbanding menggunakan hierarchical and network database. Okay, next. So what is table actually? Table means two-dimensional structure composed of rows and column. So table ni adalah satu struktur yang terdiri daripada baris dan lajur, rows and columns. Contains group of related entity occurrences, or we call it also as entity set. Terms entity set and table are often used interchangeably. So, table ni kadang-kadang kita panggil juga sebagai entity set and also called as a relation. So, tiga term yang digunakan secara bersilih gantilah, table, entity set, relation. Okay, this is one example of a table. A table is perceived as a two-dimensional structure composed of rows and column. Okay, contohnya satu table ni as mentioned here. Okay, this one. Contain group of related entity occurrences. Okay, kalau table tu berkenaan student, pelajar, so everything inside the same table will be based on about students. Okay, akan memuatkan data-data tentang pelajar. So, tentang entity yang sama, entity occurrences yang sama. So, each table, row, okay, row baris is known as tuple, represents a single entity occurrence within the entity set. So, satu baris, satu row merujuk kepada satu single entity. Okay, contohnya, student number 321452, okay, refers to a student. Last name Bowser, student first name William, everything about browser William. Okay, satu baris ni hanya berkenaan dengan seorang pelajar, a single entity occurrence. Each table columns represent an attribute and each column has a distinct name. Okay, then we move to column. Column ni satu baris. So satu baris represent attribute. Okay, attribute I have mentioned. Attribute is everything about the entity and its. Then each column has a distinct name. Okay, student last name, student first name, student date of birth. Okay. Okay. Next, each row or column intersection represent a single data value. Okay, persimpangan. Okay, intersection. Okay, contohnya, okay, nilai daripada 32, baris yang kedua, row yang kedua, second row, okay, and the third column refers to the student first name, and this is considered as one single data. Okay. Next, all values in a column must conform to the same data format. Okay, apa sahaja data yang berada di dalam satu kolom mesti memenuhi ataupun mematuhi satu data format. Okay, for example, student date of birth. Okay, satu kolom namanya student date of birth. Okay, so all the data under the same column, which is student date of birth, has the same data format, which is in the date format. Okay. Then each column has a specific range of values known as the attribute domain. Okay, specific range of values. Okay, for example, kalau dia tarikh dia of course ada from 1st January until 31st December. Okay. The order of the rows and column is immaterial to the DBMS. Okay, doesn't matter to the DBMS. Kedudukan row dengan kolom itu tidak menjadi satu isu kepada database management system. Okay. Okay, kedudukan row dan column. Each table must have an attribute or a combination of attributes that uniquely identify each row. Okay, setiap table mesti mempunyai satu attribute ataupun beberapa attribute yang membolehkan kita identify setiap baris. Okay, contohnya kalau this table about student. So how can we refer to a student's data? So we can refer to the student number. Contohnya saya nak tahu data tentang seorang pelajar di UiTM. So saya boleh gunakan panduan metric number sebagai panduan untuk saya assess everything about that student. Okay. So this is the characteristics of a relational table. Okay. This is actually what I have explained just now. So a table is perceived as two-dimensional structure composed of rows and column. Table row, known as tuple, represent single entity occurrence within the entity set. Each table column represent attribute and each column has a distinct name. Each row or column intersection represents single data value. All values in a column must conform to the same data format. Okay. For example, if the attribute is assigned an integer data format, all values in the column representing that attribute must be integers. Each column has a specific range of values known as attribute domain. The order of rows and column is immaterial to the DBMS. Each table must have an attribute or combination of attributes that uniquely identify each row. Okay. Let's look at this example, figure 3.1. Student table attribute values. Okay. Okay. For example, the domain for student CGPA is 1 up to 4. Okay. Okay. Next. Okay. Next, we move to keys.